Welcome to episode 4 of the Coincheck podcast. I am your host, Bo Bullock, and I am joined with Steve Borosh. What's going on, Steve?
Heyo, doing good.
We've also got Ralph May. What's up, Ralph?
Hey, what's up? I'm not doing good. I'm crying. Anyway.
Oh, all of us are, man. Today's been a rough day. We'll get to that soon enough. What's up, Mike? Mike Felch is on as well.
Hey, what's happening?
Everyone sounds like they're kind of off today. I wonder why that could be. I guess I should maybe mention that there's been kind of a little bit of a dip today. I don't know if anyone noticed it or not, but there's a little bit of a dip in price. But I guess before we get to that, I should probably mention what this Coincheck podcast is about. If this is your first time listening, because this is only episode 4. This is probably your first time listening. I don't know how much of a fan base we have yet, but if this is your first time listening, this podcast is really meant to kind of drive the interest from our InfoSec community more into the cryptocurrency realm, because we see it as something that's growing. It's not going anywhere anytime soon. And, we feel like there's a need to secure a lot of this stuff. So, all right. Without further ado, the terrible news of today is that the market cap has pretty much tanked for all of crypto.
Cue sad music.
Yeah, cue the sad violin in the background. So, all right, today is February 1st of 2018, and currently the overall market cap is at $425 billion, which, billion with a B is still up there, but I believe it was like 550 last week. So at least a good $100 billion or so are gone. Bitcoin is at $8,793 currently. The lowest it's been since I guess November probably, which is, obviously sad for any Bitcoin investor out there. And it's not just Bitcoin, it's across the board. Ethereum's down under $1,000 now at 967. Ripple's down under $1 again at 86 cents. I mean, that's sorry CNBC for your recommendation when it was at 3 for everyone to buy it, but yeah.
So I'm sorry, it's not funny. They lost money.
I find myself wondering what happened to the family that sold everything to live off of Bitcoin. What are they doing right now?
It's a rough day.
You hear them? Yeah.
Well, they were living like kings for a little bit. Now they're just, hoping to make by tomorrow.
In a tent in the corner crying.
Jesus.
Maybe. I don't know.
Well, it's all right. I cashed out my 401k yesterday, and so
you're buying more, right? You're buying back in.
A mortgage.
I'll buy back in. Yeah. I mortgaged half the house. All those websites kept saying that was the thing to do, so I clicked the ads, and that's what I did. So
hey, it's funny, like the whole idea of buying into cryptocurrency right now is the probably best way to do it is actually going to be mining cards really soon, because everyone's going to stop buying mining cards because they're going to see the profitability go down.
That's what I was hoping for, is that all the people that bought into that just to try it out are going to release them back on, and I can go on eBay.
I'd be hitting the eBay, man. Yeah, you're gonna be like selling them like hotcakes. I got 25 cards, man. I need them gone today, or I can't pay the mortgage.
Seriously, I mean, they're going for at least they were yesterday, going like a GTX 1070 or 1080. Normally, like a $350, $400 card should be anyway for like $1,000 easy. Yeah, I mean,
hopefully they go down a lot.
Yeah. Definitely rough to build a miner at this point. But yeah, I mean, so I guess guys, the whole market's been kind of tanking. I mean, honestly, since the end of December, it's kind of been in a slow kind of downturn. I mean, we had the big hype around Christmas time where Bitcoin went up to 19,000. Now it's sitting currently under $9,000. I mean, what do you guys think? I mean, I think I saw there was some FUD around India banning crypto for good. They came out and said something along the lines of they're going to try to completely just illegalize it, which I don't know how you really do that to a digital currency. But what are you guys' thoughts?
I don't know. I've seen some news articles where they were saying a lot of hype was about all of the scams and everything going out there, kind of making the media and kind of scaring people away. So I don't know how true it is, but
Well, I think it's a combination of all that. Like you said, the Ponzi scheme getting busted. I was reading on TechCrunch. They had an article out today about the slide being caused by a subpoena for Bitfinex, and then the concerns around Tether. It's kind of like a whirlwind of stuff going on.
Mm-hmm. Yeah, Facebook actually decided to completely eliminate any sort of Bitcoin or like ICO ads from Facebook completely. Which I have kind of a little bit of a conspiracy theory about that, because right at the beginning of this year, Mark Zuckerberg was every single year he comes out and says every single year he comes out and says that he has a goal for the year, and like one year was like he wanted to visit every state in the U.S. And then this year, his goal was to learn more about cryptocurrency. And now, sure enough, like a few weeks into the year, they ban all the cryptocurrency ads on Facebook. I wonder what that means. I wonder if maybe Facebook is trying to build up their own crypto infrastructure or something.
He probably could have solved both those year goals just by going to security conferences.
Seriously. Yeah, I mean, I bet Jack Daniel does that pretty often.
Once a year.
Yep.
I think removing the ads on Facebook is probably a smart idea. I mean, a lot of them were like, cash a 401k out, buy Bitcoin, blah, 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 right? I mean, all this stuff is the predatory ads, right? They're not really, they're get rich quick schemes, right?
Yeah.
I mean, hey, we got recipe, so.
We dealt with this a couple years back with e-cigarette advertisers. They weren't allowed to advertise on Facebook because Facebook banned it across the board for e-cigs, because it was kind of in that catch where regulations didn't know what to do with it, but yet everybody wanted it, and then it just pushed everybody to Google, and then life still went on. So I'm not really sure that it's going to stop anything.
This actually brings up an interesting point. Like, so what does a legit Bitcoin advertisement look like? Because, Bitcoin being kind of like a decentralized currency, there's no real company that's backing it trying to sell a product per se. The only people that I can imagine putting ads out there are those that are trying to either just kind of spread the word about Bitcoin or something, or trying to like get more people into it. I
bet a lot of them were ICOs too, right?
Right. Yeah.
That's the
absolutely.
thing.
Because they're
get some money going, right?
They're a company trying to make more money, right? Like they're trying to bring investors in.
They're trying to get startup capital.
Right. I'm just trying to think like what would a legit, like, just, I guess, I guess you'd have to think of it kind of like almost like the way, like, I guess EFF kind of advertises, right? Like they're trying to get more money into the EFF to help promote privacy, right? So I could see something along those lines, like an organization trying to promote privacy, or
a legitimate one maybe be like a Bitcoin exchange or some other crypto exchange being like, hey, use our exchange, we have low fees or something like that. I mean, I think that's pretty legitimate.
Yeah.
Right.
Absolutely.
I mean, there's no hard sell there. They're just saying, hey, there's competition in the market and we'd like you to check us out first, so, something like that would make sense, but to ban it across the board, I don't know. I mean, I think they're kind of making more like a statement, and that, tons of ads on Facebook are like garbage though, right? I mean, they even admitted that the whole Russian stuff and that, whatever, it's their whole model, right, is about making money off of necessarily, not the best advertisement, but as long as it pays, they don't care. So
maybe we should just agree that ads in general are garbage. And all ads.
Yeah.
And they all secretly mine cryptocurrency.
Yeah. We'll get to that story in a little bit. We definitely have that story in here. Actually, I thought of an announcement. I know we haven't actually done announcements before. We have like kind of an interesting announcement. We are going to be speaking as a group at an information security conference in Miami at Hack Miami, none other than Hack Miami. So yeah, it's gonna be awesome. The four of us are gonna get up there and actually, like, I don't know how we're gonna segment out stuff, but we'll figure it out, I guess.
I think it's good to note that it's titled Blockchain and Chill, so it's kind of relevant for our initial presence.
Yeah, not our talk. The conference's slogan.
Yeah.
Right. Yeah. Should be fun though. If you're gonna go to Hack Miami, definitely come swing by. We're gonna actually, I think we're gonna have a booth, maybe, right, Steve?
Yep, sounds like it.
So we'll have a booth. Maybe I don't know. Maybe we can come up with those in video. We don't sell to minors shirts by then.
Oh, that'd be awesome.
And then I think we're probably going to try to record an episode while we're there. So if you're doing a talk at Hack Miami on cryptocurrency and are interested maybe in coming on the show, I mean, we might be open to having you on as an interviewee. So that's going to be May 18th through 20th.
Yep, I've been to the last 4 years of Hack Miami's and spoke at them, and it's always a fun conference. So looking forward to it.
This is going to be my first one, so I'm excited. Haven't done it. It's always fun to go to the first conference, or a conference the first time. There you go.
Mm.
Yep.
Same here. First time.
So it'll be fun. Excited.
Me too.
Let's do it. Was it next week?
Yeah, you don't have the slides ready yet, Ralph? You were supposed to be on the slides.
Yeah. Ah, shit.
All right, let's jump into the news for the week. So probably the biggest news is that the largest cryptocurrency hack ever happened last week. So a Japanese exchange called Coincheck had basically $533 million worth of NIM stolen, which it's not a small amount. I think, guys, I mean, I don't think there's been a lot out there on what exactly happened. From what I saw, they were not storing stuff in a cold wallet. So the NIM were stolen from a hot wallet.
Well, that makes me wonder, like, in order for the exchange to operate, like how much do they have to leave in that hot wallet for it to actually, work? Right. I mean,
versus
how much is stored in there. Yeah.
Maybe you got some whales that want to cash out 500 million worth of NIM.
Well, obviously there was a big whale. It was the hacker, and he definitely did. Wait, why is it that always these hacks happen somewhere in Japan? Like Mt. Gox, this one. It's like always the big news items. Like, I don't know. It's always Japan. Maybe they have like a good legal system for this. I don't get it, but.
The Japanese are a little strange on their view of cybersecurity from my experience. So I don't think they expect to be hacked. And
too good.
Yeah, well, I don't think it's that. I just think they're trusting companies and stuff like that. So we'll see. Hopefully, this will be the last big one because it's it affects the market. I think that's part of the reason. Part of the reason that the market's diving too.
Yeah. Go ahead, Mike.
I was going to say they did come out and make sure that it was known that it wasn't an inside job.
Right. Yeah.
Well,
it's been interesting to note the cybersecurity side of this, and note that they're like tracking wallets.
Absolutely.
And watching. Yeah, they're watching the hacker. Apparently transferred it to like 20 different wallet addresses, and then who knows from there.
Yeah, NIM's one of those coins that doesn't actually put in any sort of randomization or an anonymity into the coin. Similar to Bitcoin. I mean, it's very well known now that it's extremely hard to hide your transactions with Bitcoin, even if you throw them through a mixing service where you basically like mix up the addresses and the transactions and stuff. It's still traceable on the blockchain to an extent. With NIM, they are absolutely tracking them. And so I was reading a quote here. It says, according to, I guess, like Reuters, the site Reuters, NIM Foundation managed to detect that hackers began sending transactions of 100 NIM coins worth about $83 each to random addresses. The NIM team is currently trying to detect the location of the hackers, but it hasn't been able to pinpoint it so far. So I don't know how like you locate physically, like where somebody is transacting exactly, unless they sent to like a wallet on an exchange or something, which I know they definitely marked the coins, so to speak, which I believe that just means marking the addresses where they're coming from for the most part. And I'd imagine that kind of alerts them whenever they hit like an exchange or something.
Yeah, what do you guys think of taking coins and essentially blacklisting them right after they've been stolen. Do you guys think that's a good practice, or does it kind of like go against everything we're working for, right? Or the reason that you would use a coin?
Yeah, because somebody then it's not really decentralized if it's being managed at the base, right, at the core.
Well, if you think about it, the exchanges can stop that from happening, right? If they have like a blacklist of these coins, and then it eventually ends up there, and they could be like, oh, well, these are stolen. We're not even going to give them back to you, right? They just seize them immediately. That's something that could happen. I don't know if it's going to. I'm just saying, like, that would be interesting.
Yeah, that's a good question. One way they could probably track it though is when there's the nodes that are communicating for the transactions, there's going to be an IP address tied to those nodes, and you could see the IP address. You could see, usually depending on the client, you see the client version information. So if they see that it went to a specific address of some sort, there might be a way to kind of look at the node information to see, like geo-IP wise.
Yeah, that'd be interesting for sure. I could see how somebody who's trying to be really like secretive or whatever could spin up like maybe a VPS, load up the node there or something, which at that point it'd be like, and it'd be up to like whatever VPS service tracking down who it was, kind of thing.
Well, don't you think that if we can track every single transaction that happened from the birth of these coins leaving, right? We could track it down to every wallet that it ended up at. Eventually when it hit an exchange, you could be like, well, that came from, historically came from a chain of wallets that was from stolen, you could absolutely figure that out. The question is whether you're going to honor that transaction or not.
Can you do that with stuff like Verge and the Wraith protocol? And that's what people are doing. They're exchanging their stuff on exchanges for more anonymity baked into other coins. You know what I mean? So
sure.
But in the case of the NEM and stuff, I certainly don't know how they're going to get it out.
Yeah. If every exchange like somehow had a system to flag coins like that didn't have that level of anonymity that some of the other coins have, right? That really make it hard to find. I don't know. And the bigger question is, it's not whether you can, it's whether you should, right? Is that something that we should be doing? So
I guess you could say the same thing for the wallets and the software. So any of the technologies that are built, if you make it so that they have to be some sort of authorized wallet, but then you're still slowly moving away from decentralization.
Yeah, absolutely.
The other thing I saw that was kind of interesting is I think Coincheck actually came out and said that they are going to actually try to reimburse the customers whose NIM was stolen. Which is,
that's good.
Yeah, that's good, right? That's a good step forward for exchanges, I think. I think that's a good example of some exchange who's not just being like, oh, you know what? Sorry, it's cryptocurrency. It was stolen, and now it's gone. And it's gone.
All that really means is cryptocurrency insurance is going to be more expensive, but
that's an awesome marketing plan, right? So make it look like you were owned and you were fully transparent and you gave back all the money, but you really just transferred it to your offline wallet.
Nice.
Yeah, that's good. That's good. That sounds all Mount Goxie to me.
Yes, it does. Yes, it does. Okay, so our next story is Coinhive and Google DoubleClick ads, which we kind of mentioned that a little bit earlier. So now, Trend Micro uncovered a spike in the number of Coinhive miners over the past few days, including Coinhive. Apparently linked to Google's DoubleClick ads that are proposed on YouTube and other sites. So they say that they observed that the number of Coinhive miner detections tripled due to a malvertising campaign, and they discovered that the advertisements were found on high traffic sites. So basically, the ads that you would typically have pop up on YouTube are now mining crypto. It's getting a little bit out of hand at this point, huh, guys?
So was it the actual ads that were being served up, or was it like when I clicked on an ad, it brought me to a mining page?
That's a good question.
Because I didn't really read the story.
Mining away.
Yeah, so I mean, it's not clear from the article that I have here, but it says, we discovered that advertisements found on high traffic sites not only used Coinhive. It does say JS underscore Coinhive, so I'd imagine it's some sort of JavaScript in the browser, but also a separate web miner that connects to a private pool.
So I could run JavaScript in an ad? That seems like something that I might have missed in my interneting. That seems pretty intense, especially through Google DoubleClick. I mean, they're everywhere.
Right. Yet another reason to block ads.
Yeah. So the one way that you can make money on the internet, we're going to screw that over.
Hey, that's not the one way. Hey, we have a donate
the
link.
most successful way. It's the most successful way.
We have a donate link. I don't. Has anyone actually like donated any mining to us yet?
That'd be nice. I mean,
I opened a tab just to see what my resources were going to spike to.
So yes, the answer is yes. That's all I had to say.
Moving on.
Just curious.
Yeah. I mean, no, think about it. I mean, every time something like this happens, it just taints the whole thing which is advertising. And a lot of sites are, literally make all of their money or able to run it via advertising. I mean, Google made their whole platform off of that. So now we want to block it in every single way, shape, and form.
Well, I get what you're saying there, but in all honesty, for enterprises, it's a really good thing to block ads for a number of reasons. I mean, first off, like just drive-by downloads and now mining malware, and then also like it just speeds up internal resources.
Yeah, it's insane how many ads your regular network pulls down. I mean, I have ad blocking at my firewall that literally black holes all the popular advertisement URLs or DNS requests, and you can actually see how much bandwidth you've saved every day. It's unbelievable, but it's definitely a smart idea just from a security perspective.
Absolutely.
Yeah, and I think from a security standpoint, like Bo said, if you block that advertisement traffic, that just weeds out a ton of traffic that is in your network that other attackers can hide in. So I think it's good to weed that stuff out from a corporate standpoint.
That's a great point. Just loading up any standard news site, you're gonna have like a million freaking news like ad hits, and trying to like sort through that along with like some obfuscated C2 channel that's going out the same web proxy. Like, yeah, good luck.
Gotta hide in the noise. Hide in the noise.
Yeah. Alrighty. The next story is actually a pretty interesting. This isn't really like a news item per se. This is more of like a new thing that is coming to fruition, I guess is to say, for like security and blockchains. So NIST is a very popular company. They have come out with the guidance on blockchain technology, and in the document, it's kind of targeted from what I could tell. I kind of read through it briefly. I didn't read the entire thing, but from what I could gather, it was kind of targeted from what I could tell to like beginners, to blockchain specifically, and organizations that were considering adopting blockchain, and to try to move beyond the hype or whatever, and kind of remind people that a lot of businesses are really tempted to jump into new technology, but they need to be sure that blockchain is really appropriate for their operations. Like, they don't need to just be like a banana company and say that, hey, I'm going to put blockchain on my bananas.
Why not? I don't understand.
Actually, that was not they did that, actually. They didn't read this NIST report, apparently.
It's very long.
I think this NIST report is fantastic. I think it's an excellent breakdown of like the entire process from genesis of the first blocks to how people mine and all that kind of stuff, and how it all just works together It's a great read for anybody, I think, other than just organizations using it for use on building some kind of blockchain super weapon or whatever they plan on doing.
The banana super weapon.
Oh man.
Yeah, but their stock went up as soon as they said blockchain, though.
Oh yeah, of course.
Except for today.
Does NIST have stock?
No, they have stock in America.
No, I'm glad to see an organization like NIST. I mean, because in security, we hear NIST all the time. Specifically around their creations of password policies and whatnot. And it's just nice to see a familiar name from the security spectrum actually taking the initiative to approach this realm and put out a real document that does actually give really good information to anyone who wants to actually dive in.
Yeah, it also adds legitimacy to this whole concept. There's just that a government organization is looking into this. Not like there hasn't been others, but it's just kind of adds that the full idea that they're there, and they want people to understand it completely. So
cool. All right, moving on. More malware, more Coinhive. Basically, so this one is called WannaMine and is playing off of the WannaCry malware name. If you guys remember a few months back, there was a huge ransomware. It was actually, I guess, probably the largest ransomware attack ever, worldwide. And the thing about it was it was using the NSA's Eternal Blue exploit, which is the same thing that this new malware WannaMine is using. So it seems like it's basically the same thing as what WannaCry was doing, except they're now mining. And so we're seeing a switch from ransomware over to mining cryptocurrency now. And I'm actually kind of interested to hear your thoughts on are they actually making much off of that, mining Monero at this point?
Oh yeah, I think there was an article we just talked about recently where the guy or whoever had hacked stuff on the internet and made over 250,000 to a wallet before they caught on. So yeah, I think it sounds lucrative to some, and it's only mining Monero consumes CPUs, so it doesn't take much to actually mine something with it.
And it's hard to detect.
Yeah, it's interesting that they're using this is almost like its own rat. I'm looking to see. I don't know what they coded it in, because they built in Mimikatz to scrape passwords and then either move laterally with that or Eternal Blue. So it's got some logic built in, obviously. So I'd be interested to see a little bit more on the code base from a security perspective.
Sure. Any other thoughts on WannaMine, guys?
Another
Eternal
one.
Blue, Eternal Blue is pretty much like every pen test that I'm on is vulnerable. I mean, I feel like I write that up in every report.
Yeah, same here. And what I found is that some vuln scanners are missing it. I was just on a test where they had scanned the network before getting there and then came on and just Nmap found it and okay, well, let's look at this. And they're like, well, we just scanned. Our super expensive Blinky Light product told us that it was okay. So
what do you mean? Blinky lights don't lead to security. Come on.
And I'm like, well, this is the perfect case, for why pen testing is important.
So I'm actually seeing PowerShell so CrowdStrike has a blog on WannaMine, and it looks like it's PowerShell.
That and WMI. Yeah, PowerShell and WMI.
Interesting.
I mean, these are all things that enterprises should be detecting on anyways, right? Anytime PowerShell runs, that should be like a flag. Okay?
For sure.
A lot of companies don't, right? I know I see it personally, but some of this stuff should be flagged.
Yeah, I think a lot of that goes into how do we collect the endpoint data and analyze it all and store it and all that stuff is usually the case that I see people. They just don't know what to do with it if they turned it all on.
Yeah, absolutely. Information overload.
Yeah, sure.
I got a ton of logs. There's a lot of stuff that happened. I don't know what it was, but in case we have to get audited, we'll be good. But detecting it, in flight or during action is a lot harder. So especially if organization's got tens of thousands of machines, it really gets to be information overload. So I do understand that.
Oh yeah.
The thing I don't understand is, like with this kind of malware that exploits something and then pivots and then runs Mimikatz and then spreads more using those creds. Like why are they using a cryptocurrency miner and not actually compromising an organization, like to the extent like stealing data, that kind of stuff? Like why are they? Is it more like just they're trying to spread farther around the world kind of thing? Like it's more of that's the interest, or like they don't have enough people
I think it's purely just money. It's just driven
faster turnaround. I mean,
yeah, and then like you could do ransomware, I guess, but I mean, then maybe the company doesn't pay.
Yeah.
Or somebody finds your sinkhole or whatever the hell because you're an idiot.
Yeah, I mean, if you really think about it, hacking a company, right? And let's say, I don't know, it doesn't matter what they do, assuming it's not maybe credit cards or something, but, let's say you get into the company, you get all their, sensitive data, you're going to hold them for ransom. I mean, that's one monetization model. What else are you going to do with that data? Sometimes, it's detrimental if that were to get released to the public, but how do you make money off of it, right? Mm-hmm. And
sure.
That's what these people are using this for. They're like, well, mining's one way to make money, ransom one way to make money. All they care about is turning this access into money. And second, getting a hold of all that data, though it may be absolutely possible, it takes way more work than just running a program that, mining, it's just.
So I mean, in reality, what they probably should be doing is just doing like watering hole attacks against like Nvidia's website or something. And just hacking
video cards.
Yeah, hacking all the miners that are already out there.
Maybe that's it.
Well, to be fair, like most of these new generation of attackers, if they are such a thing, some of I would say it seems like the younger generation that are kind of up and coming and seem to be more black hatish, what they'll do is they'll compromise the data, they'll compromise the database, and then they actually trade them and sell them. So that's why a lot of the leaks that come out are database leaks or file leaks that contain database backups. And so when you get stuff like Leakbase that come out and all those credentials, those are actually stored that are traded and sold on between these guys. And I wouldn't even say dark web because they're actually doing it like live on Twitter and stuff. So
really?
there's a monetization component there, and when they're broadcasting to whoever else does the same thing, they trade databases, they sell databases, they'll resell databases cheap. So I'm wondering, if you start looking at the demographic of who may be kind of doing this. I mean, WannaCry has been around. They're using known vulnerabilities, so you could kind of move into character adversary, attribution mode in some case and say, well, they're not using anything that's technically 0-day. They're using known vulnerabilities. They're repurposing, known malware, and that's what they're doing. And they're not doing anything super sophisticated. Even with the ransomware, when you start digging into the ransomware, the technical details behind the scenes, it's there. I mean, I'm not saying all of the ransomware is the same this way, but a lot of it, a great portion of it is very trivial. I mean, sometimes it's even written in like a high-level language like .NET, where you could actually take it back to the code. So you start looking at it from that perspective, you might get a better picture of who some of this might be. Or at least what they look like from that perspective.
Yeah, Ralph, didn't you write your own ransomware one time?
I did. It's very easy. Yeah. It's,
that's all I got to say. For research purposes, research.
Except for research purposes, right?
No, he's broadcasting live from a yacht somewhere.
It's a bunker. No, it's You are right, though. The other thing too, you could sell that access for like, botnets, or just and when we think botnets, I mean, you can use it for more than just DDoS, right? What if I just want to be able to compromise more machines from an infrastructure that doesn't attribute to me, right? So, I mean, there's all different other reasons why you might want this kind of access into somebody else's infrastructure. So, yeah, I mean, I do see there, but the big money, ransom or maybe mining at this point. I mean, I'm not sure. Everyone's chasing the dream to make the most amount of money off of this. So
I think mining still cuts out the middleman, right? So with the database, selling databases, or even with ransomware, you're still requiring somebody to make another action, which is send me Bitcoins. But when you're mining and you compromise an environment, I mean, think about that. If you have a process that's running on a server that's in your data center that's mining, are you going to call the feds? Probably not. If an attacker was in there exfiltrating your database, over a C2 channel, you're probably going to call the feds. So you're kind of eliminating the overhead from the risk, but you're also removing other people, and you're just mining. And it's just, so I while it's completely bad, I still think that there's a lot of benefit to these guys that are doing this that would cause them to kind of go that route versus trying to monetize another route.
Kind of to your point, I wonder if we'll see something similar to basically the attackers, getting into an organization, doing legit hacking and stealing of data, and then trying to cover their tracks with something like mining. To do exactly what you just said, hey, we saw a bunch of miners that we got hacked. We got this random WannaMine malware on our network now. We'll just get rid of it, kind of thing.
Yeah, well, with some of the nation state attacks, that's really what happens, right? So they'll get in, and in order to get out, they'll cause a smoke screen. They'll cause a denial of service somewhere that gets the security team kind of and the ops team kind of running after a different problem, so they could use that as a way to get out. So it's a good point, though.
Cool. All right. Our last story for the week is there was a critical vulnerability in the BitPay and CoPay wallets. So basically, before version 3.14, the BitPay and CoPay apps wrote new wallets' private keys to the device storage at wallet creation. So if you were to create a new wallet and then go to encrypt it, it had already been written, at least the private key portion of it, to disk prior to encryption happening. So the risk there is that either A, somebody was already on the system and was able to see that private key or something, or I guess forensically, right? You have the copy of it there on disk.
Yeah, this is a common problem. I mean, this is especially with mobile devices. You get mobile devices, and what they'll do is they'll store everything securely, but they'll write a key to the storage unit. So if we do a full disk extraction or a full image of that phone, we could carve out data and recover it, and that's ultimately where it leads. So this is just piggybacking off kind of some of the known problems that are there. Now they're affecting private keys, and so this is probably more prevalent than what you think. I bet you if you found some of the wallets that run on mobile devices and tried to do some full disk image recovery or even dumping the memory, you're gonna see stuff. I bet more and more frequently.
Absolutely, and yeah, BitPay is one of the larger companies out there that has a wallet. So it is interesting to see these types of vulnerabilities. This is exactly why we have this podcast, because I want to bring this kind of stuff to attention, because I think that vulnerabilities like this, like what you just said, it's probably more prevalent. It's a very common thing that absolutely in mobile apps you see it all the time. It's probably likely that companies that are jumping into this spectrum are going to have similar problems too, and maybe not thinking of the risks there.
Especially the newer companies, the faster they come on the scene, the probably the less time that was taken to secure their products or applications. Everyone's trying to get it out as fast as they can. So you're right. We will see more of this. And this particular example, I mean, I'm sure it's common among other apps too that aren't quite as sensitive, especially. And I'm sure even BitPay's got a decent security team, right? That other companies might not have the resources for. So
True.
Yeah.
All right. Well, that's it for the news. Anyone else got any things they want to add to any of the news stories before we jump into the next section? I'll take that as a
good
no.
Yeah.
So I was talking with Mike about potentially doing like a series of some of the specific vulns that are related to smart contracts, because there are a number of them that I think that should be covered almost like at an individual level to kind of get a better understanding of some of these newer vulnerabilities that are making their ways into smart contracts. So Mike, I think, has put together a few things to talk about.
Cool, yeah. So what I was thinking, what we could kind of touch on just a little bit, I wanted to put a little bit of focus on Ethereum smart contracts, and I think the reason why it's so attractive kind of to me is because it has a lot of tech involved, right? There's a lot of there's code and there's compilers and there's development frameworks and there's IDEs. And the other thing is with these smart contracts being immutable and fully transparent, it's really difficult to write secure code already to begin with. So when you start looking at code that's being pushed publicly that anybody could call and interact with, I figured, just spending a little bit of time on some of these vulnerabilities that are kind of not saying they're all primitives for smart contracts and blockchain, because I think some of these overlap with your typical application vulnerabilities. But I was just going to step through just a few of some of the common developer errors that have been occurring during my research, and a lot of the stuff that that I know as it relates to what's threatening secure contracts and ICOs, and especially ERC20 tokens, is really just piggybacking off some of the research that I've been doing from people that have already laid the way, like Zeppelin, and then there was a really nice white paper by a few people. I think it was called a Survey of Attacks on Ethereum Smart Contracts. It was put out by Nicola Adzi, Massimo Bartoletti, and some other Tiziana. I don't know. So I guess what I'm saying is a lot of the stuff that I'm going to talk about real quick is it's kind of out there. It's kind of just consolidating a lot of the attacks that have occurred and kind of stepping through. So some of these. Like the first one is an integer underflow, right? So a lot of these balances, so you can imagine like a smart contract contains state, it's self-internal state, and so the state gets updated whenever transactions get called to a contract. So there's like conditions that have to be met, like if the sender is making a call to a function, for instance, and there's a transfer of currency that's going to be made, there's these conditions that have to be met, because once again, Solidity, the programming language on Ethereum, is Turing complete. So with the integer underflow, what we've seen is that balances that are being updated kind of within a contract, if they fall below zero for whatever reason, because a lot of these balances are using unsigned integers, it could actually wrap, right? So with an underflow, you could send a transfer, and let's say that it underflows below zero, it's going to wrap to a much larger balance. And so you can see how something so trivial could actually cause, like a less than or equal to, for instance, instead of just a equal to, or some sort of math equation that's going on, could actually cause the balance transfers to create a much larger amount than what was expected. And so looking at it just as the code, it's kind of hard to pick up on some of these nuances. Another thing that I've seen kind of plaguing, I don't really know what the technical term for this is. I just called it schizophrenic functions because it sounded cool and it kind of fits what I was
coined. It's coined. That's what's going to be schizophrenic functions. That's awesome.
So the idea is that so because there's an internal state and because it's all based on stack, like in stack space in the virtual machine, what happens is you have these storage indexes, and every time you have a variable that gets instantiated inside of a contract, it's actually stored at a specific index on that internal contract storage. And so what tends to happen is sometimes contracts will change names, and some of these contracts get really large. The function names change, or they'll leave a function name in the background, and they'll change the name of it. But because of that's an initialization function or something that sets like who the owner is, they leave some of that code lingering. And so, or what'll happen is they'll either have a mix-up between function names and variable names. And so, if let's say that you're deploying a contract to the blockchain, and you're inheriting a shared library out there, because everybody knows that rolling your own code, if there's already an existing one that has been around for a while, is like such a great idea. The reality is when you load these libraries, and they have these imports with inside of them, if there's any mix-up between the function names or the variable names, it could cause an overwrite on the storage index, where let's say that the owner address is set in that contract. And so like if you have an initialization function that was not removed, it was not deprecated whenever they changed that contract's name, it can still be called from a transaction. And so you can imagine having a contract that's out there that's vulnerable to this, and then kind of importing it, and then causing a mix-up, and then being able to trigger the owner address being overwritten with your owner address, and then calling like another init function or a transfer function and kind of draining the wallet. So that happens. And kind of piggybacking that, there's these delegate calls that also happen, and basically, like, let's say that you have like an unknown method in a contract, but you're using a shared library, and there's a fallback call that could be made so that when you're using that shared library, like let's say that there's a function call that's in there that you can call a init on that shared library, but you don't have it in your main contract. So you're basically calling a function in another contract. The delegate call will actually execute as your initial contract. So let's say you have a parent contract, and let's say you have a shared library contract. And let's say the parent contract doesn't have an init, but the shared library does. If you deploy your parent contract to the blockchain and you're using something where there's a delegate call there, an attacker could basically call that delegate call in that shared library, and it gets executed under the context of the parent. And so what happens from that perspective is that's kind of back to the parity kind of issue that happened a while back. It allows an attacker to call the initialization again on a wallet or on a contract that was never initialized. And so because of that, that owner gets set as whoever sent that transaction, the message.sender that sent the transaction. And so when you get into these delegate calls and these fallbacks happen, reinitialization of these contracts can happen, and ownership can be stolen basically. And then you'll see a transaction that gets made to the contract where the owner gets updated to the attacker's address, and then that attacker just transfers all the money back out, or all the currency back out. It's a fairly large one. So there's that, and then there's also the reentrancy. I know we've talked about this, I think briefly, maybe not. I don't know. I've talked about this a bunch, but this reentrancy vulnerability is super awesome in that it's using like a recursive call. So you can imagine deploying a contract that has a shared library again, but if that message sender's balance is updated after the transfer, and there's a recursion process that's happening, then what can happen is it can get into this infinite loop where the transfer continues to happen because the shared library recursive call calls the transfer function, and then it tries to check to make sure that it's empty, and then it falls into this recursion loop where the reentry keeps happening on the same transfer function. And because the messenger sender's balance doesn't get updated until after that transfer happens. And so this type of situation kind of happens a lot, where a wallet will get drained before the balance ever even gets updated, and you kind of run into kind of all kinds of little problems with that. So making sure, I guess the key to that is making sure that the message sender balance gets updated before the transfer occurs. That way, in case you get into this problem, at least the balance was there, and so it's kind of interesting. I mean, we could dig a lot on a lot of these. So there's those kind of problems. You know, I didn't think about this until now, but you know, one of the other things that I've seen too is when there's like an unpredictable state of that contract, and so like let's say that a lot of these, if you've seen like these smart contracts, while yeah, they're Ponzi schemes, but there's also a lot of games that people play, and there's organizations that people kind of chip in and kind of join and create, and so it's kind of turned into like this organic game place where people can kind of go play like these Ponzi schemes, and it seems to be super popular. But one thing that's kind of affecting it is when you're a player of one of these games, and another player is also making transactions to the game, but they're also mining. And so what that kind of causes is an unpredictable state, because if you're mining these transactions, you could create new blocks with like a delayed timestamp, or you could prioritize the blocks that you're mining, and so that you're always the winner. Or you could lock it where you trap that contract into a state that forces like the fallback functions to fail. And so what tends to happen is these smart contracts either get denial of service, or an attacker becomes the winner, kind of taking the Ponzi keepings, or so to speak. So these are just kind of some of the developer errors that I've been digging into a lot lately, and it's fascinating if you're into application security, or if you're a pen tester that really likes like web applications or reverse engineering. I think they would probably have a lot of fun digging into the technology behind this, because some of these vulnerabilities are just, it's kind of weird to wrap your mind around, but it just keeps getting so deep. And so I'm pretty amazed at just how well Ethereum kind of put this together, and how they put that out there. So obviously can't just talk about all the problems with developer errors that are affecting smart contracts without really kind of talking a little bit about what we can do if you're developing, or if you're an organization that's pushing it, or if you have a technology team that's kind of implementing some sort of blockchain for bananas. What you can kind of do in order to mitigate some of this before it even gets pushed into the kind of the production Ethereum network, so to speak, and not the test network. One of the first things, and a lot of these tips came from Zeppelin, so and they kind of carry over from traditional software development. But with securing the smart contracts, I guess one of the things that I try to do just in my daily life is fail fast. Like if I'm trying to do something, if I'm trying to pursue something that's new and I'm researching a problem, I always try to fail fast. It's like one of the big things I do: fail fast and fail frequency, and then learn, from that mistake. But failing fast and loud will immediately stop these issues from perpetuating to other code areas where you have less insight, whether it's shared libraries or whatever. So make it so you're separating your code into in an organized fashion, right? Because if you could do that, then you could manage all of the conditions that are met first, and make sure your if then else statements are all there. If the conditions are met, then move on to the actions where you're actually checking and altering the internal contract state. And then if there's any sort of interaction with other external contracts, which you can do that last. So if you organize your code in that way, you'll be able to fail fast, and you'll be able to set up events that are loud and exceptions that kind of alert with your contract code. The other thing that you could do is pulling transactions instead of pushing transactions. I've seen this a lot actually with recommendation within the Ethereum kind of the spec, and then also with tips that I've read kind of researching some of this. It kind of solves for the reentrancy problem too. So allowing users to pull their transactions as necessary and separate that code from any of the internal transfers. So another thing that you could do too is also is set your limits. So set your limits within the contract, but also know that because these contracts are going to be compiled into bytecode and processed by a virtual machine, the Ethereum virtual machine, understand that the EVM, the virtual machine, has its own limits. And so, because if you don't understand the limits of the virtual machine, an attacker is going to leverage those limits and those restrictions and push it to the max in order to get your contract to act in a way that it wasn't built for. And then the other thing is, if you set limits within your contracts, like let's say funding or transfer limits, you can minimize the impact quickly. So if there is an attacker that's starting to drain your wallet, if you have limits that are in place, you can kind of minimize those impact of those transactions in time to kind of have your failsafe, whatever that failsafe is, in time to kind of to mitigate it. And then the other thing that I would say is there's a lot of really awesome tools for developing these smart contracts. There's security frameworks that you could implement that you could actually boil straight into your code at development time, so that when they get compiled, they're checked. There's tools for auditing now. So Open Zeppelin is an awesome security framework put out by Zeppelin that really helps mitigate a lot of these problems. Another one that's an awesome scanner is called Mithril. Mithril could actually scan these Solidity files. It could scan the actual bytecode. So if it's already compiled, it could actually scan a contract that's live on the blockchain as well. And it gives you kind of a range of problems. And obviously, because it's looking at the bytecode, it doesn't necessarily know, like, oh, at this storage index, this is an address. It just knows that, storage index 5 can be updated by calling this function, and also storage index 5 is used to transfer funds. So it'll tell you kind of the path on the execution path of the contract, but it doesn't necessarily tell you like specific details, but it's super awesome. So use security frameworks, use a good development environment like Truffle or some of these other ones. I think even Microsoft is coming out with something for Azure, ether.camp, which is like a complete Ethereum IDE. And so, yeah, those are, I think, some pretty good mitigation steps to kind of get in and start, developing and playing with it. That's really what I did. I just built my own coin at first because I wanted to really get familiar with like the whole life cycle of development. And so once I started digging in and started questioning, like, well, what about this? And what about this? I kind of just stumbled across other people that already had similar research that kind of solved those problems. But I have a feeling that we're not even looking at the tip of the iceberg here.
Yeah, the other thing is this is just Ethereum that you're talking about right now. Like these are just smart contracts on Ethereum. I mean, there's a number of completely different blockchains that also do smart contracts. I mean, there's probably similar stuff there, but
yeah, that, and once again, we're talking about blockchain. We're not even talking about wallet security. We're not even talking about, address generation security.
Right.
This is just one portion. I think this is also the reason why I'm so passionate about this, is because it's such a wide open. It's wide open right now. There's only maybe a handful. I could probably count on one hand, maybe two hands, of people that have put either blog posts out, research out, or gave talks on the security of this stuff. And as much as the security industry jock it and kind of give it its grief and the stigma that comes with it, I mean, just the technology behind here is enough to get me passionate about it. But if the security industry kind of in general tends to overlook it, you can imagine the damage that's going to come unless somebody starts, because we're having this great divide where less security professionals are getting involved and more businesses are adopting. So there's this divide that's occurring that could have like 1990 Wild Wild West all over again.
Yeah, I mean, blockchain's become just a buzzword on Twitter. I mean, that's it. Like anytime I see anyone actually in our industry tweet or talk about blockchain or cryptocurrency, it's usually joking about something. I like you just said, I don't think I've actually ever seen anyone that I follow on my like legit security feed, like not the crypto side at all, talk about securing cryptocurrency. That's another really main reason why I wanted to do this.
Yeah, that, and you got these big companies and these big exchanges that are trying to go real professional with it. Who's doing the pen tests? Who's doing the auditing? Who's doing the source code analysis?
Exactly.
That's why I liked Electronium off the start, because they had once they realized there might be security concerns, they went through HackerOne. Right? So yeah, I just hope other coins and ICOs adopt that mentality and get tested.
Sure, but even with HackerOne, I mean, are you going to have somebody who has actually looked into smart contracts. You know,
That's a good thing, because they did a private bug bounty, and who knows who's actually doing it. I mean, really. So I don't know what they got out of it. What code review? I don't know. It could have just been an external test. Who knows? But
right, or like maybe
I think it was at least a step in the
test.
direction.
Yeah.
Yeah, sure.
Yep. Cool. So, Mike, I just had one more question for you about that section. So, I know whenever you were first kind of, when we first started talking about this stuff, you were showing me there was a site, I think it was by Zeppelin, that it was almost like a CTF kind of thing for smart contracts.
Yes, it is awesome. It is called Ethernaut. It's ETHERNAUT dot Zeppelin, ZEPPELIN .solutions, and the idea is that they have a bunch of different levels here that kind of that if you just install like MetaMask, the Chrome extension, and open developer tools, if you go to the Ethereum test network and transfers just some Ether to your test wallet. If you log into like the Ropsten test network and then go into the developer tools, it'll actually give you you could use the console and interact directly with it. And what they'll do is they'll create these new instances of these contracts, and the goal is to basically hack the contract. So it's teaching you like first how to look at some of the promises, the JavaScript promises that come back in the developer tools, so you can kind of navigate the stack. And then as you're progressing through these levels, they have like 10 levels or 9 levels, and each one kind of builds off the other. And so some of them is like taking ownership, and they're using a lot of these contracts are actually built around historic breaches that have occurred, like the DAO and some of these other ones where like reentrancy was a legit contract. This was a legit contract that was out there that was actually breached, and so they deploy it, and your goal is they kind of walk you through, they kind of build you up and give you a little bit of a guidance in that direction. But it's super good for getting pen testers or your security team kind of up to par, or even your developers up to par on how these vulnerabilities exist. And so it's super awesome resource. And Zeppelin in general is an awesome resource.
Awesome. All right, guys. Well, I think we've hit our time limit for this episode. So I really appreciate you guys joining me once again. So thanks for coming on, guys. And and then next week we'll be at it again. Make sure you follow Coincheck Podcast on Twitter. Keep an eye on coincheckpodcast.com. We are going to actually put the show notes on there, I swear. So, soon. We'll do it this week, right? I think. And then subscribe to the podcast on your favorite podcasting app. And we will see you next week. Thanks so much for listening.
See ya.